Thank you all for being here, and I think this case study with Ed Epler, who's the CFO of Beta, is perfectly timed after what we just heard as Paris is preparing for the Olympics and eVTOL operations next year. Ed, to start us off, where are you with the certification of your vehicles? You have both a conventional, there's two different versions. There's the conventional takeoff and landing, and then the VTOL.
Well, thanks so much, Leanne, and thanks so much for having us here at this event. And kudos to Paris and Volocopter, because I think it's actually spectacular that they're going to be demonstrating the aircraft here at the Paris Olympics next year. As you can see in the videos, so Beta Technologies is a developer of electric aviation. We are certifying two variants of that aircraft. One is going to be flying like a conventional airplane on just a pusher prop, and the other is a vertical takeoff and landing aircraft when you have four top rotors that will be basically a lift plus cruise configuration. We're thrilled about the advancement of this technology. We think it's both greener and more sustainable for aviation, but it's also more economic. And we've decided that the big hurdle for everyone here is path to certification. So as I'll talk about it, we are on a path to certify the airplane version first, and then with the vertical takeoff and landing version shortly thereafter.
So why did you choose the airplane version first? Can you kind of walk us through where you are and your methodology?
Sure. What I'll show here is a quick picture of both variants of the aircraft in flight test. We've been flying actively over the last several years. So compared to some of the other businesses here, we've flown the conventional, the CX-300 over 22,000 miles. We've gotten permission from the FAA to fly it more broadly in the national airspace. So we've done flights all the way from Vermont, which is where we're headquartered, down to Bentonville, Arkansas, and back. We went out to meet with the Secretary of Transportation in Louisville. We've been flying airport to airport on a regular basis. And then on the right, what you see is the vertical takeoff and landing version with the top rotors. This next image, I think, will really help set it straight. So what you can see is there's about 85% commonality between the two aircraft. So the big difference is you just don't have the lift kit and the forward boom on the wing, but the aerostructure is substantially the same. It's a fly-by-wire, all-electric aircraft. It's the batteries are still in the belly of the aircraft. So we think about 85% of the certification basis is covered in the CTOL, or conventional takeoff and landing variant, and the vertical takeoff and landing variant really has just the top lift rotors and lift kit, and that's been our path. The good news is the CTOL aircraft is certified in the FAA as a Part 23 aircraft. So there are no special conditions. The FAA knows what the rules are. So we've already been working through the certification basis and means of compliance and are rapidly towards the path of thinking about testing this aircraft for our ultimate certification in 2025. When you get into vertical takeoff and landing aircraft, the certification rules are still in some respects being defined. So the FAA has decided it would be a powered lift aircraft where they would choose elements of Part 23, Part 25, Part 27, 29. And we're working through that process just like some of the other public companies have announced, Joby and Archer, and we're basically going through that same process contemporaneously.
So speaking of the development, you have stepwise integration. Can you tell us what that is and why you're doing it?
Sure. The way we think about it, and we use the expression frequently, crawl, walk, run, we've decided that what we're trying to do is incredibly innovative for aviation in general. And so what we want to try to do is not make it a binary, do all things at once, but where can we think about making progress and a more active entry to service. And so one of the things is we're focused on both military and commercial markets. So we have the Air Force and Army as customers. That's incredibly helpful for our flight testing and product development. Recently, as a milestone last year, we had test pilots from the Air Force who flew our aircraft and from the Army. And that was incredibly helpful in convincing the FAA to put 3 test pilots in our aircraft as we think about trying to get that further validation and qualification. In the commercial markets, we've started, and we were actually probably the first company to focus on the medical market. The Beta was founded with a launch customer, which is United Therapeutics, who is a leading organ transplant company. And we basically started with medical and cargo as our initial market. We think it's easier for the FAA to certify a cargo aircraft. So our aircraft has a 50-foot wing and 250 cubic feet of cargo capacity. It can be a single pilot with 5 passengers or 3 full pallets. So UPS is our launch cargo customer. And so we think that basically building thousands of hours as a cargo aircraft will help build passenger trust, and it will help give people confidence that there's the safety of the aircraft that we all hope and want. And so that's been our approach. Once we've proven that as a conventional takeoff and landing aircraft, as I said, there's 85% commonality for the vertical takeoff and landing variant, and I think that that'll help, again, build that trust. So that's what we mean when we say stepwise.
Thank you. Well, that also, we've had the last several panels, we've been talking about public acceptance and also with the use cases. In the last panel, they're talking about the hospital and transporting doctors, organs, people. So it's interesting that, there are so many different applications for the electric vehicles that I think we need to think about.
Definitely. I think some people have thought that Beta is a cargo-only focused company, and it's really not. I mean, the way we think about expanding our total addressable market is in this stepwise function. And starting with cargo is very economic for our customers. Our second largest shareholder is Amazon. We think it's a very valuable use case, and we have strong demand for that, but we also think it's going to help on that certification path.
So let's talk about charging stations and batteries, since we're talking about electric aircraft, very important. Can you walk us through how you're setting up this infrastructure, what the network is now, what will it look like, how these things will be charged?
Sure. So our founder and CEO, and I'll go back to the pictures of the aircraft actually flying. So our founder and CEO, Kyle Clark, had the philosophy that what good is an electric airplane if you don't have a way of charging it? And we wanted to go to our customers with a holistic solution. So Kyle's 2 previous businesses were in power electronics and controls. He had a history of developing grid-tied energy storage systems. And he basically was focused on developing charging systems, which are now being bought by our customers and, in fact, some of our competitors. And he's developed a universal standard that others are plugging into. But we've actually started building these charging systems around the country. So when we flew to Bentonville, Arkansas, which is about 1,600 miles and back, we used our own charging infrastructure along the way. And it's been designed to be multimodal, so you can charge both electric ground vehicles and aircraft, and it's designed to be open. So it ranges from 200 to 800 volts. You can charge a car at a 3C rate charge, and you basically charge the aircraft in less than an hour. And we're also developing mobile charge trucks, because what happens if you land in an airport where you can't charge? We've developed technologies and ways to actually very rapidly hot swap batteries. But we think that the value of the network, similar to what Tesla has done, is incredibly valuable. And we're already installing it. And I think by the end of the year, we'll have close to 20. We have basically 60 additional sites in some stage of design, permitting, construction, and about to be switched on.
So sustainability is, a key part of, this whole industry in the pitch, but you still are building infrastructure, you're using electricity. So, to cut down the case, is it really more sustainable, especially with all the electrical use?
So, it's a good question. So one of the nice things about being in Vermont is Vermont is almost entirely powered by sustainable energy. It's 97% sustainable energy. A lot of that, candidly, comes from Hydro-Quebec, but there's also a lot of wind and solar in the state of Vermont. Other states are catching up. One of the benefits of the way we've designed our charging infrastructure is that we put battery storage. So after the aircraft basically has been flying and batteries hold a lower state of health, you can then put them onto the grid for energy storage, and it allows you to basically trickle charge into the batteries and then rapidly recharge the aircraft quickly. It also allows for load balancing and microgrids and the use of renewable sources, whether or not people are thinking about solar or wind, to trickle charge these batteries. So we've tried to design our charging network to actually facilitate and enable sustainable energy.
That sounds good. Is that unique to Beta?
It is. I think the beta's probably been farther along in thinking about how are you going to develop a charging network than anyone. The FAA is also all about open access and open source. And former director Billy Nolan was commenting that he likes the way that we've designed our network to be open. It uses a CCS interface. It's not like you're going to end up going to an FBO and say that they only have fuel for your Gulfstream or they only have fuel for your Cessna. And it's all about open access. Currently, our charging systems are at airport locations, and we've been partnering with municipal airports and FBOs and others to basically put this infrastructure in place. And then ultimately, with the vertical takeoff and landing aircraft, we'll be putting them at our cargo customers' distribution hubs, and then at hospitals and other locations. So we'll build this charging network, but today it's all at airports.
Okay, so these charging networks can be used by multiple. Is it kind of like an ATM? You know, we all have an ATM card that you can use at multiple banks, and there's a standardization. I mean, are we going to get to that part from a charging station?
We hope so, and we hope it's going to be ours. But what's actually kind of fascinating is if anyone's basically used your Tesla vehicle, as soon as you plug it in, it knows it's your vehicle. It knows that it's your credit card attached to whatever you're charging. We've gone through multiple designs of our charge cubes, and actually it's designed the same way. So you actually also can load an enormous amount of aircraft health and information after every flight. So how the aircraft is being used. So we're designing an open network that you basically plug in, and all of that information is preloaded. We're developing a software app so you can go to an airport and know which airports are which charge systems are open and available. You can schedule a reservation. We're trying to think really about how people are going to employ electric aviation. And as I said, some of our competitors have already been approaching us to do that.
So let's continue on the operations conversation. What else is going to be needed from a maintenance standpoint, training? How's this all going to roll out, and how are you going to ramp up?
So one of the things that we're really focused on is demonstrating real-world performance and being able to go to our customers with a holistic solution. So I talked about the charging. I didn't really talk about simulation and pilot training. So at Beta, we're close to a little over 500 employees. We will teach anyone to fly who wants to learn to fly. We have close to 400 people in our flight school. We have a dozen CFIs. And we're very focused on pilot training, not only to make our own employees more aware. You take a battery engineer and then you basically make them learn how to fly, and they become much more sympathetic to the cause. But we're also focused on, because it's this company of aviators, we're very focused on the maintenance and sustainability of the aircraft. So we just completed construction of a 25,000 square foot hangar, which is going to be a maintenance and training facility. We've announced a partnership with CAE. We have our own simulators that we've built and have deployed out at Edwards Air Force Base and down in San Antonio at Det 62. And they put close to 100 Air Force aviators through our simulation and pilot training programs. So we are really thinking about it from pilot training all the way through to the maintenance of the aircraft. And we're basically figuring out how we're going to sustain that. I think the other thing that separates, if I can go there, Leanne, Beta is we're very focused on flying our aircraft piloted in real world missions. So with the FAA's permission, we've gotten the opportunity to fly under what's known as a market survey, which is allowing us to fly airport to airport. It's allowing us to fly internationally to Canada. It's allowing us to fly at night. And we're basically exercising the aircraft in real world ways. And so for us, that's the best proving ground and the best learning ground.
Have you gotten to fly it yet?
So it's a really good question. We have 4 official test pilots. I am not yet a test pilot. I do have my private pilot license, and I'm working on my instrument rating. We'll hope to have close to 9 by the end of the year. And we've just recently gotten permission to start flying with some of our technical subject matter experts, so people who are on our motors, inverters, and other teams. So we're now actually flying with others in the aircraft, and hopefully by the next air show I'll be able to say yes.
Okay, we'll follow up on that.
Okay.
And I just realized I forgot to say, if you would like to ask any questions, go to slido.com and just type in PASAM, and then I'll get the questions here on this handy iPad. So send me questions if you'd like to ask any. So what is the one thing that most surprised you when you joined Beta and you started learning about the aircraft?
It's a great question. I had been an investment banker to the aviation industry for 20 years prior to meeting Kyle Clark. And actually, I worked with him on his Series A financing. So we raised about $370 million with Fidelity and Amazon. And then I basically decided to join him and continue to help build the business. And you have to visit Beta. What's amazing is the passion for what we're doing. We have an incredible culture of people. I mean, basically, people share three passions: a passion for technology, a passion for sustainability, and a passion for aviation. And it's very different than some businesses where you're just trying to pull people out of Silicon Valley potentially or other geographies who are hoping to be part of the next thing. We have just an incredible. I mean, if you visit it, it's active 7 days a week. Everyone is in the office. We have, because we will teach anyone to fly, we have a ton of aircraft, including a lot of personal aircraft, including now my Cirrus. And there is this enthusiasm for what we're doing that's really unique. And I had the opportunity in my prior job to work with a lot of really smart people. The youth and energy and passion that's at Beta is really the thing that probably has surprised me the most. It's awesome.
Mm-hmm. Sounds good. Any questions from the audience?
So the question was, do we have any plans for the UK? And thank you. So we absolutely have plans for international expansion. One of our customers, UPS, recently received a minimal viable license to actually operate our aircraft in the UAE as a pre-certified aircraft between Dubai and Abu Dhabi. Another customer, Air New Zealand, has been leaning into their growth. We think about it as an international market. We have been speaking with the Civil Aviation Authority in the UK, as well as working closely in Ireland. And so as we think about coming to Europe, it's very much part of our plans. We don't have an active certification currently with EASA, but we're working very closely with them and designing our aircraft to be compliant with those EASA standards. And so yes, the UK is on our roadmap, but we don't yet have a presence.
Speaking of certification, given the differences between FAA and EASA certification, do you have any concerns there, or do you think the bilateral is going to kick in and start making this process easier? What do you think?
Look, I would say publicly and privately, we've spoken a lot with the FAA about the benefits to the industry of harmonizing between the two. And I do think that, for a lot of reasons here in Europe, EASA has been very focused on sustainability, and in some respects, some people would say maybe the FAA has been a little behind. And I think the FAA has been challenged with a lot of things coming at them, and certainly after the MAX, there's a little bit of trepidation. But I think there's a recognition that this is real, and it's happening, and it's for the global benefit of aviation for them to create alignment. And so I'm enthusiastic about that. The FAA reauthorization bill is currently in front of Congress currently. There's funding to support staffing and advancement of this industry. There's funding potentially for electric vehicle charging at airports, which is going to unlock some of this other funding in the U.S. around this. So I think the U.S. is getting very aligned with EASA, and it's a global industry, and there's the benefit of being aligned. So I do think it'll come together.
That sounds good. And you said you're planning on certification in 2025?
We are. So we've made a decision to certify our propulsion system. So we own and control our propulsion, and we're certifying that under Part 33, and we hope to have that in 24. And we're looking for the CTOL variant to be certified in 2025, and the VTOL variant in 2026. Okay,
so the next Paris Air Show will be 2025. So will it be flying before then?
Well, currently it's flying live.
Certified. I'm sorry. Will it be certified?
Will it be certified?
Yeah.
So I hope so.
Okay,
So I would say that hopefully we'll be able to fly our aircraft here to Paris, and we'll be able to show it to the world. As you know, we don't have a booth here, and we've been very focused on spending our R&D dollars on actually developing and flying the aircraft. But yeah, in 2025, I hope to be at the Paris Air Show.
Okay, because then we can see, we'll expand this
Well, hopefully we'll be on a static display and showing the aircraft in one of the demos.
That sounds good. Yes.
Sure. So for VTOL, the use case, one of the things that we found was that there were some customers that really wanted runway independence and other customers where it was optional. I think the vertical takeoff and landing and runway independence is a real unlock for a lot of great applications. I would say that with our military customer, they are principally focused on the VTOL application because it opens up a lot of opportunities for them in cargo and logistics, but where runway independence is particularly important. We've announced a relationship with Blade, who is, some people may know, is probably the most, the biggest urban air mobility provider of helicopter services now. And we also have a customer relationship with Bristow, who flies more helicopters than anyone in the world, except the U.S. Army maybe. And both of those customers are very focused on VTOL for passenger movements. I think for some of the airlines, they're very focused on both cargo and passenger. And I would say for a lot of the couriers, starting with runway to runway where they have a lot of their infrastructure and distribution facilities now is very viable for them. But ultimately, being able to go direct distribution center to distribution center with a VTOL aircraft is very important to them. So I think it will evolve. There are good use cases. It's sort of a Venn diagram where there's a bit of overlap for some customers. Some are CTOL only or some are VTOL only.
Do you expect to sell more of the conventional takeoff and landing or the VTOLs? What is your projection?
I think ultimately the opportunity for runway independence in VTOL is going to be a larger market. I think that the CTOL is its own very big market, both in military and commercial. But I think the opportunity to be able to unlock and move away from a runway is enormous. But
sorry, how much do they cost?
So directionally, $3 to $4 million for the CTOL variant, and $4 to $5 million for the VTOL variant. I would say that the more important thing, though, is total cost of ownership. And so people might say, well, compared to other airplanes that are similarly sized, it's a more expensive airplane. But for example, when we were flying from Bentonville, from Vermont to Bentonville, and we were flying 150 or 200 nautical miles in a given leg, we were using $16 or $17 of electricity, and our chase plane, which was a Cessna Caravan, was using $700 to $800 of Jet A, right? So the fuel savings are enormous. I mean, 30, 40 to 1. The maintenance of electric vehicles is dramatically lower. The total operating cost, the biggest piece of it, is ultimately needing to replace your batteries every 1,000 or 1,500 cycles. But even when you absorb all of the capital costs of the aircraft and the operating cost of the aircraft and the maintenance and fuel on a per block hour basis, it's probably about half the operating cost of a conventional takeoff and landing aircraft, and going to be a quarter to a third of a helicopter. So dramatically lower cost, even when you consider a potentially higher cost for the aircraft as a capital cost up front.
Speaking of maintenance, are you going to have a network of service providers, or how is maintenance going to work?
So one of the interesting things about electric aviation is the maintenance cycle on the motors should be much, much longer, but also it's very easy. It can almost be line maintenance. The pusher motor is 150 pounds and can be swapped out in less than 2 hours by 2 people. So if you compare that to something like a PT-6, and you think about how long it would take to disassemble that from the aircraft, what it takes to do an overhaul, it's dramatically longer and much more difficult. So we're going to think about working with maintenance partners. We're building the ability to train maintenance people inside the Air Force and at other customers. So we're very focused on how it's going to be maintained. We'll probably have partners around the world. In some cases, some airlines and customers like UPS have their own maintenance crews, and in other cases, we'll have partners.
That sounds good. Any other questions? Yes.
It's not it's not going to be easy to swap the configurations. What you'll see in some of the photos is that we do fly it. Well, it's not going back, but that's fine. We do fly it with those forward booms, okay. So on the left-hand picture, as you see in the graphic here, the conventional takeoff and landing aircraft won't have that forward boom, but we're already doing a lot of flying currently with that forward boom, which is there. So there's an attachment point, and you could swap the booms, but I don't think practically that will be the use case. I think that most customers will decide, I mean, just like you look out here, they're aircraft that people use for specific purposes, and they'll want something which is relatively tailored, but it's not like you're going to go reconfigure the same aircraft, I don't think.
Sounds good. Well, Ed, I know you have a flight to catch, but thank you so much for being here, and really appreciate your time. And thank you all, and enjoy the rest of the Paris Air Show. We have the next panel will be with Eve Air Mobility, and then we have a concluding panel after that. So 2 more sessions after this, so stick around.
Well, Leanne,
Ed,
thank you so much. It's really great to be here.
Thank you, Ed.